Hi, today we will learn about reactivity series. So, what is reactivity series? Reactivity series is an arrangement of metals based on their order of reactivity. Order of reactivity, does that mean the metals have different reactivity? Yes. For example, let's say I add calcium, copper, zinc, and magnesium into test tube containing hydrochloric acid. As you can see in the picture, calcium reacts more vigorously compared to zinc, magnesium, and copper. As we can see from the picture, calcium is more reactive than magnesium, followed by zinc and copper. This shows that the different metals have different reactivity. Therefore, this is the need for us to arrange the metals in a reactivity series. In reactivity series, we arrange the more reactive metals at the top, followed by the less reactive metals. Looking into the reactivity series in detail, we can see the first three positions are taken by the elements from group 1. As we know, group 1 are the most reactive metals, and followed by the metals from group 2, which are next in the line as the reactive metals, and followed by group 3 and the transition metals to the most unreactive metal, which is gold. Okay, now we're going to look into how to remember the order of this arrangement. How are we supposed to know which comes first? Are we supposed to memorize? Is it possible for our students to memorize and remember it during exams? No. So now let's look into how to remember the arrangement of these metals in the reactivity series. A good way to remember the order of a reactivity series of metals is to use the first letter of each one to make up a silly sentence. And there are many examples available in the internet, and we will look into a few of them. For example, people say little children make a zebra ill constantly sniffing giraffes. So you see, this P belongs to potassium, sodium, lithium, calcium, magnesium, aluminium, zinc, iron, copper, silver, gold. So this gives us the easiest way to remember arrangement of metal in a reactivity series. And there are more than this. And this is another way of remembering the reactivity series. Please stop calling me a careless zebra, instead try learning how copper saves gold. Here we have more metals compared to the earlier mnemonic that we have learned. So here we have also included carbon, tin, lead, hydrogen into the reactivity series. So by remembering this sentence, it will be easier for us to write down the arrangement of metals based on their reactivity. So now we will learn what is the need to know and to understand the reactivity series. It will be to understand displacement reaction. So what is displacement reaction? Displacement reaction is all about a metal displacing another metal in its compound, which means a more reactive metal will displace a less reactive metal from a compound. So we have a more reactive metal and less reactive metal compound. This more reactive metal, they can react easily with a compound. Therefore, they will replace this less reactive metal to form a more reactive metal compound and less reactive metal. And this is one example of displacement reaction. So when we add aluminium to iron trioxide, we will have iron and aluminium oxide. Can you see aluminium is displacing iron from its oxide and produces aluminium oxide? So now we will look into the reactivity series to know which of this metal is more reactive. As we can see in this reactivity series, we can see aluminium is at higher position compared to iron, which means aluminium is more reactive than iron. Therefore, aluminium will displace iron. So because aluminium is more reactive than iron, it displaces iron from iron oxide. The aluminium removes oxygen from iron oxide and reacts with it. So looking at this, we know that when we add zinc to magnesium sulfate, there is no reaction. This means magnesium is more reactive than zinc. Therefore, zinc will never displace magnesium. By looking at the second reaction, zinc is at higher position compared to iron in the reactivity series, which also means that zinc is more reactive than iron. Therefore, zinc will displace iron from its sulfate and forms zinc sulfate and iron metal. Looking at the third one, zinc and copper, and we know zinc is more reactive than copper, so it displaces copper from its sulfate compound and forms zinc sulfate. Okay, I think we have looked into enough information about reactivity series and displacement. Now let's try to answer checkpoint past year question. So looking at the question, Connor and Arnold investigate the reactions of metal. In their first experiment, they place small samples of different metals into test tubes. They then add copper nitrate solution to each test tube. Connor and Arnold repeat the experiment with different solutions. They use new pieces of metal each time. The table shows their result. So when there is a tick, it means a reaction takes place, and there is a cross, that means there is no reaction. So now looking into this question, we know magnesium is more reactive than copper, iron and lead because they can displace copper, iron and lead from their compound. But for iron, they can only displace copper and lead nitrate. This means iron is more reactive than copper and lead. Copper does not displace any of the metal from their compound because it is less reactive than all the other compounds. So now use the information in the table to put the metals into their order of reactivity, starting from the most reactive to the least reactive. So when we compare the information given in the table, we know magnesium is the most reactive metal. Therefore, magnesium comes first, followed by iron, which can displace two metals. So iron, then lead, followed by the least reactive will be the copper. So here we go. Magnesium, iron, lead, and copper. Okay, let's summarize of what we have learned today. Today we have looked into what is reactivity series, how metals are arranged in a reactivity series, and learning reactivity series we have also looked into displacement reaction, and we have also answered a question based on displacement reaction and reactivity series. Hope you have learned something today. Thank you.